Okay, hi guys, this is a calculus video, recovery video 7, and this is the video that you'll watch if you want a refresher of the U substitution technique. Okay, so the clue that you will be using U substitution is that none of the techniques above will work. All right, so you asked yourself, can I use power rule? And you answered no. You asked yourself, can I use the f prime over f formula? And you said no. You asked yourself, do I know a formula for the antiderivative of the input? And the answer was no. And then finally you said, can I use long division to rewrite the input? The answer is again no. So you are now at your last resort and you're trying U substitution. And okay, so recovery video 7. I decided to do a definite integral here. A definite integral, remember, I need dx at the end. Did I forget that in the last recovery video? No, I didn't. Okay, so I decided to do a definite integral. Remember, the meaning of this definite integral is not the antiderivative. That's not the meaning of it. The meaning of it is the area under the curve. But the fundamental theorem of calculus says that if I want to compute a definite integral without a calculator, I need to find the antiderivative, put it in some brackets with the upper and lower limit at the end of the brackets, and then that step is getting me ready to plug the upper and lower limits into the antiderivative and subtract. Okay, and that's how I will find the area under the curve. That's what the fundamental theorem of calculus says. Now, I have to use U substitution. So I'm going to let U equal a function that I see is inside of another, and I see that sine of x is inside of e to the blank. Okay, so I'm going to let U equal sine of x. Now, because this is a definite integral, well, actually, let me just go through I'll go through this other stuff first. So now I'm going to find the differential of this. So du, that's called the differential, is equal to cosine of x. I like to put parentheses around those. Cosine of x dx. So dx is equal to, you could do du over cosine of x. I've seen some of you do that. Or you can go 1 over cosine of x du. Okay. So now the thing about definite integrals with U substitution is that you have to change the limits of integration. All right, right now these represent x's. Okay, so x equals pi over 4 and x equals pi over 2. That's an interval of x values that we're integrating over. We are changing everything to be in terms of U. So I have to say to myself, if x equals the lower limit, pi over 4, then since U is equal to sine of x, U is going to be equal to sine of pi over 4. Okay, so U is going to be equal to sine of pi over 4, I believe is radical 2 over 2. I really hope I'm right. Yes, I believe I am right. Okay, radical 2 over 2. So that's what the lower limit is going to change to. Now I have to change the upper limit as well, which is pi over 2. So I have to say to myself, if x equals pi over 2, then U is equal to sine of pi over 2. So in this case, U will be, for the upper limit, U will be 1. Okay, so now guys, I've done all of this side work. I am ready to do the substitution up here. So this definite integral is changing into the integral from the lower limit is going to be radical 2 over 2. You don't have to write U equals, but I'm doing that just to be super clear to my reader. This now represents a value of U. And then the upper limit changed to 1. Now, what happens inside? Okay, what happens in the input of this definite integral? Okay, cosine of x, I have nothing to plug in for that. Okay, I'm hoping that cancels. And then e to the u. And then what's going in for dx is this stuff right here. Okay, so 1 over cosine of x du. Those cancel. That's what I wanted to happen. So now everything is in terms of u. I'll just bring down that equal sign. The integral from square root of 2 over 2 to 1 e to the u du. And this is going to work out super nicely. Now, the point of u substitution is you take something complicated and you turn it into something more manageable. Now, to use the fundamental theorem of calculus here, I would open up a bracket, okay, set up the limits of integration at the end there, and then what goes inside of here is the antiderivative of the input of the definite integral. And there is not an easier derivative or antiderivative in the world. The antiderivative of e to the u is simply e to the u. Okay, e to the blank, that's the function where its derivative is the same and its antiderivative is the same. And then, so the way that this works is that I do e to the 1. These are values of u now, so I can plug them in. So e to the first minus e to the radical 2 over 2. So e minus e to the radical 2 over 2. And that's a number. Okay, it's an irrational number, but a number nonetheless. And this represents the area under the curve of that. And it wouldn't be a bad exercise to plug this into your calculator using Math 9. And then also plug this in your calculator and you'll see you get the same decimal. Okay, guys, have a great day. See you soon.